Good morning, Youth Build. How's it going? I am Ian Solano. You should know me by now. If you don't, what the heck? Where have you been living at? Today we're going to be doing something exciting. We're going to be multiplying polynomials. Now, what is multiplying polynomials? Well, all it is multiplication. Standard multiplication, really, but with variables included. So in the last video, what you were technically doing was like terms, right? Combining like terms. But in the core of it all, it was pretty much adding and subtracting polynomials, right? It was basically saying, how do you do this problem? Well, pretty simple. 2x plus 4x, all it equals is 6x, right? That was combining like terms. Because it was the adding symbol, right? Multiplication has its own separate rule, and you must distinguish this rule, because if not, you're gonna really get it confused with the combining like term aspect, and it's gonna throw you off completely. All right. For instance, using that same 2x and 4x as an example, what's 2x times 4x, right? Somewhat similar to the combined like terms. You still focus, let me use a different color, you still focus on the numbers. But instead of adding like we did last time, we now multiply because that's what our symbol is indicating, right? So what's 2 times 4? Well, pretty simple. It is 8, right? All right, we're halfway there. Now what about the exponents? Oops, not exponents. The variables. What about the variables? What's x times x? Now before, in the last video, x plus x, all it was x. You know, we just threw on the variable and we called it quits, right? Not in this case. Multiplying does have its own rule, and you must really keep track. If not, like I said, you're gonna screw yourself up. X times x, what it ends up being is x squared. Why? Well, remember what I explained a while back? I think it was the last video. Was it the last video? I'm not sure. There are invisible ones as that variable's exponent. Am I right? So x1 times x1 creates x2. Do you see a pattern there? Yes. You pretty much add them. That's all it is. You add them in order to get the new exponent. Let's say this had a 3 and this had a 2. What would the answer be? What? I can't hear you. What, you're saying it's not like terms and it can't dish out an answer? As in, this is your answer because they're not like terms and you can't do anything? You're wrong, all right? Multiplication, multiplying polynomials does not care about like terms, all right? It doesn't matter whether those are different. It don't care that this is an x and let's say, oops, and this happens to be a y squared. That's a 4y squared, by the way. It doesn't matter. It does not care. Multiplication does not care. It just says whatever this is, you multiply it by that. By using the same steps that I'm telling you what to do, you multiply the numbers first, which in this case is 2 times 4 equals 8. X cubed times x squared. Again, you add those exponents together to create x to the 5th power. All right. Now, using another example, let's say this is x3 times 4yx. Actually, let me throw away the x. Let me just use this as an example so far. What does that create, huh? Again, you just focus on the numbers. What's 2 times 4? It is 8 again. What's x cubed times y, well, all it is x cubed y. Because you can't really do anything with each other. But you could still combine them pretty much and throw it on the answer, all right? Multiplication does not care. All you do is get that and you times it by that. The whole thing, right? So that's the rule with multiplication, all right? Multiplying polynomials. And it's key that you keep track of that. Let me throw one more example. What's this first step that you got to do? Just focus on the numbers first. What's a negative 3 times positive 6? It is negative 18. 6, 12, 18. Yep, I am correct. All right. Okay, what you want to look at it as is this x cubed times those variables. What's x cubed times x squared y squared? Well, again, you focus on the x's, right? Which creates my x5, and then the y2 just gets thrown on there because you can't do anything with this and that, right? So that is how you solve multiple variables in one problem. That was pretty much a monomial times another monomial, am I right? What happens if you happen to have a monomial times a binomial like this? All right? What do you do there? This is really important, you guys. We're entering now into the distributive property, all right? Now, do you remember Pemdas, order of operations? Go back to my video 1 if you don't. It says parentheses first, right? That reigns supreme amongst all. That's the number one rule in all of math. So it still applies here, all right? There's a parentheses here. Can I do the inside? No. Because as you remember in our combined like term video, you cannot actually do this operation. You cannot do 3x plus 3 because they're not like terms, right? So Pemdas, even though it wants me to do the parentheses first, there's nothing to do in this parentheses. We can't do the inside. So we got to move down. Is there any exponents? No, there isn't. Is there any multiplication or division? Yes, there is. It's pretty much saying this monomial times this binomial. That is why we do what we do right now, which is called the distributive property. All right? We have to multiply this times both of the terms in the inside. Again, before you were just doing 1, right? This times that is the same thing, except now we're doing this times that, then again that times this, all right? So it's just an extra step. Don't get too intimidated by it. So let's actually do it. What's 2x times 3x? Well, what it is 6x squared, am I right? Now follow the second arrow. What's 2x times 3? Again, multiplication doesn't care whether they're like terms. You just do the actual problem. So 2x times 3, well, 2 times 3 is 6 again, right? Positive or negative? It's a positive because both of them are positives. X times no x, all it is x, right? And that's your problem, right? So it's not that complicated when you really think about it. The reason why I had to mention the whole Pemdas very quick is because a lot of people see a problem like this and they say, I'm going to do the inside because I have to because of Pemdas, right? Which is fine. But like I said, you can't do it because of the actual operation telling you that it's adding, and you can't add them because they're not like terms. Now, let's say, I'm just trying to throw a whole bunch of stuff at you so you could get this nailed down. This is the most important video, I think, right? Let's say you have a 3x, oops, sorry. Well, let's say you have a 3 plus 3. It's virtually the same as the last one that we just did, except with the x inside the parentheses. What do you do now? Again, you have Pemdas at the top of your head, parentheses first. Could you do what's inside in the parentheses? In this case, you can. 3 plus 3, all it is 6, right? And now you just have a basic monomial times a monomial, which 2x times 6 equals what? 12x. So distinguish the two. Pretty much, you could do standard operations inside parentheses, and pretty much you can't do standard operation if there's a variable involved and they're not like terms, right? So we look to multiplication to bail us out, to create our simpler answer. Because all we're doing is simplifying pretty much. We're not dishing out a real answer, as you could tell. That is not a real answer. That's just a simpler version of that. So yeah, so we already did monomial times binomial. Then we added another step, a monomial times a binomial on the inside, right? How about we step it up a notch? What happens if we have, let's say, 2x plus 3 times 3x plus 2? Oops. This, my friends, is still using the distributive property, except this one is different because it obviously involves a little bit more work. But this is what you'll see more of in the test, is this whole problem right here. Something called FOIL, all right? Don't worry about the acronym. Don't worry. All we got to focus on is the same thing that we were just doing just a second ago, which is distributing, all right? We are actually multiplying each one to each one. It's a step-by-step thing, pretty much. It's called FOIL. So we're going to do this first one times this, then that. Am I right? Then all you're going to do is move on to this next term and times it by that, then times that. You have to remember the arrows. You got to follow these arrows. It is key. It is key. So how about we do it? How about we do it? Come on. Boom. All right. So what's 2x times 3x? Well, all it is 6x squared, right? What's 2x times 2? All it is positive 4x, right? Now we move on to the next one, this one right here. What's 3 times 3x? Well, what it is, oopsie, 9x, right? Because 3 times 3 is 9. Then our last step, this 3 times this 2. What does that equal? Well, all it is a 6, all right? No variables in that last one. Let me erase this very quick. So that problem that we just started with has now become this, right? Now, I'm going to give you 2 seconds. Could you spot anything in particular with this problem? Is there anything that you could do here before you call it quits and you say, this is my simplest version that I could get this FOIL problem into? You better have spotted it, if not, I'm going to be mad. Couple videos, last video, I just taught it to you. Combining like terms, right? This is 1, and this is 1. Positive 4x plus 9x. That becomes 13x. All you're doing is simple addition there. All you do is simple combine like terms. You have to spot that, right? The rest we haven't touched. The rest can't be done with anything, right? Involved with it. Oopsie, let me rewrite that better. So because they cannot be touched with or messed with, you just bring them down. It's plus 13 because this is a positive 13x, right? Even though it came out horrible. And then this is a plus 6 that I just brought down, and boom, there's your answer. That's how you FOIL. That is how you multiply a binomial to a binomial. Pretty cool.